Hello students, I Bhagya MP, Assistant Professor, Department of Chemistry, Sai Vidya Institute of Technology. Today I am going to teach you Module 3, that is Energy System. So in this today's session, what I am going to teach you is, I am going to teach you Introduction to Energy, Fuel Definition, Classification of Fuels, Definition of CV, GCV and NCV, construction, working and calculation of bomb calorimeter. So let us start with the introduction to the energy. As we all know, sun is the main source of energy. Energy means it is a capacity to do work, and there is a law of conservation of energy is there. So according to the law of conservation of energy, energy neither be created nor be destroyed, but it can be transferred from one form into another form. So in this energy, there are two types, renewable and non-renewable energies. Renewable means which can be regenerated and non-renewable means which cannot be regenerated. So when it comes to the non-renewable energy sources, fuels are one of the primary energy source. So in the earlier days, fuels are used for only cooking, lighting and heating. But nowadays, because of the modern civilization, so fuels are need for the transportation, illumination, manufacturing and other applications. So fuel means what? It is a kind of energy source. So what kind of energy we are going to get from the fuel? So from the fuel, we are going to get a heat energy. So then what is the definition of fuel? So the definition of fuel is, the fuel is made up of carbon substance. And those carbon substance are mainly serve as a source of heat and light. So in another way, we can also say it as, so fuel means it consists of organic matter. So when these fuels, it undergo combustion in the presence of oxygen and it produces a heat. So along with the heat, some products are formed. So that is the total process or total meaning of the fuel. So now let us start with the classification of fuel. So in this classification, there are two types, primary fuels and secondary fuels. What do you mean by primary fuels? Primary fuels means which are naturally occurring. So it's already present in the nature. Secondary means which can be obtained or derived from the primary fuels. So when we consider the states of matter, that is solid, liquid and gas. So in the solid, so what is the example we are going to get it for primary fuel is coal, wood, lignite, peat. So these are the examples for primary fuels in solid in nature. But when it comes to the same secondary fuel in the solid, so that is charcoal and coke, means from the coal, so we are going to get a charcoal and coke. So that's why these belongs to the secondary fuel. Same way, when you consider the liquid state, so crude oil comes under primary fuel. From the crude oil, we can able to get a kerosene, diesel, synthetic petrol. So these comes under the group of secondary fuels. So when it comes to the gases, biogas, it is comes under the primary fuels, means biogas is naturally present in the nature. But from the biogas, we can able to get water gas, producer gas, LPG, etc. And these gases comes under in secondary fuels. So this is about the classification of fuels. So now let us discuss calorific value. So what is that? What do you mean by this calorific value? Calorific value means, see, if you are measuring quality of a fuel, so that quality of fuels are measured in terms of its calorific value. If you consider any fuel, if that fuel calorific value is more, means we can say that fuel has a good quality. So then, what do you mean by this calorific value? So calorific value means the amount of heat liberated by burning a mass of fuel in the presence of air is called as calorific value. That means when you take some amount of fuel, so when it undergo combustion in the presence of air, so as I explained, when the fuel undergo complete combustion in the presence of air, it produces a heat. Along with the heat, the products are formed. So the whatever the amount of heat is produced by the fuel, so that amount of heat is expressed in terms of its calorific value. So if the amount of heat is more, so we can say that that calorific value of that fuel is also more. Means calorific value is a qualitative measurement of the fuel. So in this calorific value, there are again two types, gross calorific or high calorific value, and this abbreviation we call it as GCV or HCV. What do you mean by this gross calorific value? Simple way I'll explain it. See, as we know, when the fuel is burned in the presence of air, it undergo complete combustion and it produces a heat, and also some products are formed. So what happens in the gross calorific value is whatever the products are formed after the complete combustion of the fuel in the presence of air, so those products are cooled to the room temperature. When you cool to the room temperature, so that we call it as a gross calorific value. That means in GCV, we can able to measure the amount of heat liberated from the fuel. Also, we can able to measure the latent heat of water. So the next question raises, how do we get this latent heat of water? Because of the cooling the product. So when the fuel is completely burned, the products is always the liberation of carbon dioxide and water. So once the products are cooled means the whatever the water is released, it get condensed and we are going to get a latent heat of water. So in the gross calorific value, we can able to measure two things. One is the amount of heat liberated by the fuel, also latent heat of water. And that latent heat of water we are going to get only after the complete cooling of the products which is released from the combustion of the fuel. So the next is net calorific value or less calorific value. Abbreviations is NCV or LCV. So in this what happened is here also the same process. So the amount of heat liberated when you burnt a fuel in the presence of air, but the only difference between NCV and GCV is in the GCV we are going to cool the product, but in the NCV after the complete combustion of fuel the heat is liberated along with the product is also formed, but here products are not cooling. Whatever the products are formed, it is directly allowed to escape to the atmosphere. Means combustion products are allowed to the atmosphere. So in this case, we are not going to get a latent heat of water value. So here we can able to measure only the amount of heat liberated by the fuel. Then how do we calculate NCV? So NCV can be calculated by the formula GCV minus latent heat of steam of water. So this is about the calorific value, GCV and NCV. Next is determination of calorific value of solid or liquid fuel using bomb calorimeter. So in this bomb calorimeter, we are going to discuss construction part, working and calculation part. The first let us start with the construction part. What do you mean by this construction part? Construction means whatever the diagram you are writing or whatever the diagram you are seeing, the same diagram if you explain it, that gives the construction part of this bomb calorimeter. When you look into this, so this is the full diagram is the bomb calorimeter. Then how do we explain this construction? Let us start with the from one point. Whenever you are going to explain the construction part, always you start with one point and end with the other point. Same way, here also I'm going to start with the middle point. So what is the first point? See, this is all is bomb. So what I'm showing in the cursor, this whole part is a bomb. It is a cup shaped bomb. Okay. So this bomb is consists of a one crucible. This is in the side you can see it crucible. So in this crucible the fuel is placed. What is that fuel? Is a yellow color what you are seeing. This is the fuel. Means the fuel is placed in the crucible and the crucible is there in a bomb. And this bomb, it is in contact with the wire. What type of wire we are using is, either you can go with the iron, magnesium or copper wire. Any one of the wires we can use it. So this magnesium wire or iron wire, it is in contact with the fuel at the one end. At the other end, it is in contact with the battery. Also, this bomb has an inlet for oxygen supply. Why there is an inlet for oxygen supply? Because whenever you ignite the fuel, so this fuel undergo combustion only in the presence of air. So in order to provide the oxygen supply, this bomb has an inlet for the oxygen supply. And this whole bomb is, after this whole bomb is closed it very tightly, and this bomb is placed in a calorimeter. See, yellow color what you are seeing in the box. So this is a calorimeter, sorry, a blue color, and this blue color is consist means it is a water. That means this whole bomb is placed in a calorimeter which consists of a water. And in the calorimeter, we have to place a thermometer and a magnetic stirrer. What is the role of placing thermometer in the calorimeter? Means thermometer is to measure the water temperature, and the magnetic stirrer is placed in order to maintain the uniform heat temperature in the water. So after that, this whole bomb calorimeter is closed with the air jacket and water jacket. What is the purpose of closing this whole bomb calorimeter with the air jacket and water jacket? Is the purpose is to prevent the loss of heat to the atmosphere. So this is about the construction part. Now let us come to the working. Working means how it works. So this is construction part. So when I come to the working, so working is very simple. See, as I explained, the fuel is placed in the crucible, and this fuel, it is in contact with the wire on one side, and the other side it is in contact with the battery, and it has a oxygen supply, this bomb. So the oxygen is supplied from the outside, that is in through the inlet. Also the fuel is ignited through the wire. So once you ignite the fuel, what happens? As I said, the fuel undergo complete combustion and it produces the amount of heat. So whatever the amount of heat is produced, where it will go? It doesn't escape to the atmosphere. Why? Because the whole bomb calorimeter is covered with the air jacket and the water jacket. Then where it will go? That the amount of heat liberated by the fuel. So that amount of heat is completely absorbed by this water which is present in the calorimeter. So once the water absorb the heat, so what happens? Immediately the water temperature get raised. That water temperature we have to note down that. So that is the working of this bomb calorimeter. So that's what I'm going to explain it in this slide. So working means, first the fuel is placed in the crucible. Then the initial temperature of water is noted. Which water? The water which is placed in the calorimeter. Next is oxygen is pumped into the bomb, and the fuel is ignited through the spark produced by the iron wire. So once the fuel get ignited, so it undergo complete combustion, and some amount of heat is liberated. Whatever the amount of heat is liberated, it is completely absorbed by the water taken in the calorimeter. Finally, the water temperature is noted down. So this is about working of bomb calorimeter. Next is observation and calculation. Coming to the calculation part. So let us consider the weight of fuel taken in the crucible, let it be m generally. The initial temperature of water, let it be T1 degree Celsius. Final temperature of water, let it be T2 degree Celsius. Change in temperature, that we can call it as delta T. Weight of water taken in the calorimeter, let it be W1. water equivalent of calorimeter, that is W 2 kg, and specific heat of water is S, that is denoted as S. Then how do we calculate GCV? GCV can be calculated by the formula W1 plus W2 into delta T into S divided by M. Then how do we calculate the NCV? What is the formula of NCV? NCV can be calculated using GCV minus latent heat of steam. But here NCV is equal to GCV minus 0.09% in 0.09 into percentage of hydrogen into latent heat of steam. So now the question raises, how do we get this 0.09? So how do we get is, see, water. What is the formula of water? Hydrogen plus half of O2. So according to this, 2 gram of hydrogen produce 18 gram of water. Because 18 gram is a molecular weight of water, hydrogen molecular weight is 1, but here 2 molecules are there, means 2 gram of hydrogen produces 18 gram of water. If 2 gram of hydrogen produces 18 gram, then 1 gram of hydrogen produces how much? 18 by 2 into H by 100, that is equal to 0.09. So that is what we have written it here, 0.09 into percentage of hydrogen into latent heat of steam. So by using this equation, we can able to calculate NCV of the fuel. So this is about today's session. Thank you.